Hi guys, you guys something fun. Okay, so we're gonna do rehacking today. This is a low-level code that has nothing to do with the kernel. So we are bypassing every kernel security to boil down to layer 2 of the OSI model and hack out our broadcast MAC address, our actual source MAC address, and the protocols behind our MAC address, which is the ARP, address resolution protocol. Okay, so this is gonna be like really low level. I'm gonna be doing this on C. Okay, so stick with me as we proceed. Okay, so I clear the screen and I'm gonna make a directory here. No, I'm just gonna change to the one I have called raw socket. Alas, so this is a GitHub repo though. So I'm gonna change to crafting here. So I have some few codes here on layer 2, but this is a new one. Okay, so I'm gonna call this Mac. I'm gonna do vim, so it's called mac.c. Yeah. Okay, so I press enter. We start writing our code immediately because I don't want this program to be, very long. All right. So I'm gonna include some few header files here. Okay. The sockets, which allows to create a network, and I'm also going to include the ARPA, which is ARPA/inet, which allows to use the the header files, which is this the sock addr_s_ll. all right, so that's the structure we're going to be referencing to get those attributes of a socket header file. All right, so the next thing I'm going to be doing here is I'm going to add a Linux / Ethernet .h, so we can get every Ethernet. No, we should use the interface _packet. Yeah, interface _packet.h. right, so we're better off with that. Then here now we can now include the inet, the net inet, okay, /ether.h. okay, I think this is pretty much for now. If there is need for any more header files, we just come and fix it immediately. So let us try writing this code immediately. Int main, that wasn't spelled right. So I'll be using the exit system calls, which is gonna exit success. All right, so this is pure C code, so don't worry. If you don't see, then you should be able to flow with me. But if you don't know C, you're going to enjoy the end product of this. So you understand what protocol is all about. That protocols are actually numbers, just as I said, port are also actually numbers. So I'm going to get that number of the protocol, which actually represents ARP. Okay, so I'm going to create a socket here, that is a sock. Okay, so this is just an integer. All right, so I'm also gonna create an unsigned char here. Okay, so I'll call this the buffer. So this buffer will be the memory. So I'm gonna say 65,500 and 65,536. Yeah, I think that's a appropriate number. So if I'm making a mistake there, I'm gonna come back and fix that. So I'm gonna say struct equals to the socket. So here I'm creating the socket here. So to bypass the kernel, just as I said, I'm just gonna use the address family called packet. So this is the lowest level we can go. All right, so then the next thing here is the socket. I'm gonna tell the kernel that I want to do everything myself, which is raw. So afterwards, I'm going to use host to network shop open bracket /p_all. All right, okay, so this allows me to live on that layer 2 protocol. So the next thing I'm gonna do here is so I'm supposed to close two brackets here. I would like to check for errors. All right, I would like to check for two errors. I like to check for errors on this, so I'm going to say this less than 0, then we encounter error. So I'll be using the printf, okay, to send the error to standard error. All right, to standard error. Yeah, so I'm going to say err number, all right, %d, so get the error here, and I would like a string of what that error looks like. Okay, yeah, so new line, then I'm gonna say pass error number, and we need a string error, so here we also pass the error number, and that is it. So because if we encounter an error, we like to exist the program here, so I'm gonna say exit underscore failure, so the computer should end there and return. So another time I'm supposed to have add here is hash include error number .h and hash include the string .h, so that we don't face any error, because I am using the string error here. So where this function is defined is in the string error file here. All right, so that is it. So and again I'm supposed to also include the stdlib, okay, .h, because I'm using the I'm not making mistake in the name, okay, uppercase I here. All right, so because I'm using this exist here, so I need that stdlib.h, and here should be semicolon, not colon, and that is it. So now we have just create a socket, okay, at the lowest level of the system. So we are in the lowest level right now. We're kind of like talking to our NIC, which is network card interface, right? So we're gonna do this frame and send it to the wire and capture our broadcast MAC address, our source MAC address, and our protocol, right? So for us to do this, I'm just gonna write do a quick printf here. I'm gonna do a quick printf here. So I'm gonna say listening. All right, I'm gonna say listening here, right? So let me just listening. All right, so once I'm listening, so what I'm listening for is what I'm about to do next, right? So I'm going to jump into a while loop. So the while loop here, I'm going to set it to true, which I need to define up here. So I'm going to go up here, I'm going to define a micro here, hash define true, I'll say 1, right? And that is what this true is going to represent. So it's going to take us for infinite loop. So in this infinite loop now, we need to receive from. Now we are doing the capturing. So we are receiving from, so we'll pass the socket, comma, and I will pass that buffer memory address. And the next thing I'm going to do here is I would like to get the size of this buffer. So using the size of to get it, which is of a character. So we are getting this in 1 character at a time. So the buffer here, so comma, then the next thing I'm going to pass 0. 0 means I'm reading. All right, so and then once I'm done with that, I'm going to pass null, right? Yeah, so I close that semicolon. All right, so let's do a quick printf here. So this printf here right now, we're going to talk about the destination MAC address. So I'm going to say new line, for example, because I don't want things to jump out together. So I'm going to say destination. No, that wasn't spelled right. Destination. So I'm going to put a colon here. So in this destination, or let me just say destination MAC, then I cannot put my column. Yeah, so it looks nice now. So I'm going to say percent let me say percent %02, because MAC address are always 2 bytes. So 2 bytes is 16 bits, so I'm going to put it 2 there. So and I'm gonna pass x because it should be in hexadecimal, so this is uppercase x, the same thing. All right, so when I separate that with column, so I will do percent 0 to uppercase x, column again, it's gonna be 6 of them, percent 0 to uppercase x 3, percent 0 to uppercase x, which is 4 right now, percent 0 to there's no percent there, there should be percent 0 to uppercase x, which is 5, then the last one, percent 0 to uppercase x. All right, so that's it. Then the next thing here, we'll put comma and we'll close that. So we want, you know, to now pass the appropriate buffer. So we are reading from the memory right now, so the memory of buffer 0, so whatever that will be stored there is the MAC address, guys. So that we get that and send it to this first one, so that will store in this first one here. So 16 bits we stored here, which is this 0. So so that's how we're gonna do it till we get to the complete. So I'm gonna do the same buffer, all right, 1, okay, comma again, buffer 2, okay, so now it's 3, all right. So buffer this should be 3, comma buffer, and this should be 4, and buffer, and this should be 5, and that's it, is complete. All right, so it's up to 5, then we just close this and put a semicolon. Right, so that is it for that. So after that, we're going to do the one for the source. Okay, I think this is going to give us a jumper code, kind of like a jumper code here. All right, so in this next print here, I'm going to put a new line before we write. So what I'm going to do is, instead of, you know, writing everything from scratch, I'm just going to copy this line. So escape 1 YY, that has been yanked. I come down here and I press B and I paste I for insertion. So I'm going to change the destination MAC address here to become source MAC address. Yeah, so everything you're going to look the same, everything here is just the same. Okay, everything here is just the same. So the next thing we're going to do next is the buffer here. We're going to change it, so it's going to continue from 5. Okay, so it's going to continue, so the next is going to be 6, here is going to be 7. So we are reading from the actual memory. Okay, 8 7 6 7, here is going to be 8 here, and here is going to be 9 in here, and here is going to be 10, and here is going to be 11. Okay, if we don't do this, we're gonna, like, you know, print same MAC address. All right, and we don't want that. So now that we are done with that, the next thing we're gonna do next is that I'm gonna, like, you know, create an unsigned short for protocol. So I'm gonna call this proto. Okay, so I press semicolon. So this proto is gonna be holding the, we're going to do a simple calculation here, buffer, then we are shifting left 8 bytes, and we close that. We are using the all bits to see. We are also saying the buffer of array 13, so which is when we have 2 bytes, so the 11 plus 2 bytes is 12, and we continue from what, 13. So instead of here, I'm going to say from the 11 there, so we have the address 12, we shift 8 bytes, and there we use the bitwise operator or to do the rest calculations, and that will land us on the appropriate protocol, right? So this is just a protocol calculation, and the next thing I'm going to print here is that protocol. Okay, so I'm going to say new line, I'm going to say protocol, I'm going to say colon. So this time around, this protocol is always 16 bit, which is 2 bytes. So I'm going to do shift I'm gonna do shift percent O2, no, because it's 16 which is 4 bytes, so we're gonna do 4. All right, then yeah, percent S, then I'm gonna give a new line here and command, then pass the proto, and that is it. Okay, so this is a very simple code, a very nice one that will give us what we really want. Okay, so let's just test this out. Right, let's test this. Everything works very fine just as we build. So escape shift colon, then I'll do gcc is called mac.c. right, so I'm gonna do output it to become mac. Okay, we have a very simple error here. Say hash include, yeah, that's just a very simple one. So let's go fix it. So I was putting / at the front here, which not supposed to, so I removed that. And let's go compile again, and you got it. You still have an error here. So vmac again, let's see what the error is all about. Linux / if packet. Okay, the packet wasn't spelled well. Should be E. Yeah, sorry, most times I do typing mistakes, guys. So our code compiles. So ls we have the mac, you can see it there. This is the mac, you can see it here. So I'm gonna run it. For us to run this application, we use sudo. If we run it without sudo, just watch, it's gonna tell us permission denied, operation not permitted. And if we look at the error number here, okay, the error number space -l. Okay, yeah. So if we go up, if we look at the error 1, because that error is error 1, you can see what error 1 is talking about. You guys can see it here. You can see error 1, guys. You can see error 1 here. E-prem, you can see it. You can see my mouse, right? E-prem, talking about permission denied. At the same time, our code here will compile, give us permission denied. So the error is coming from error 1. So we don't want that, which means because we have permission denied, we don't want this, so we need sudo to run this application. So we do sudo /mac, and we should get every of our mac address. So it's asking me for my password. Just input my password, and we are listening. So let's wait for this and see if it was able to capture all that. Let's see if we are able to capture all those MAC address. Let's wait and see. Okay, let's wait and see. Are we receiving from that socket? Are we receiving from that buffer memory? It's wasting some time. It's not supposed to be. It's wasting some little times here. Remember there we are in a loop, so we're trying to use a read from to read from that memory that address is stored. Yeah. Oh, guys, you see, we got it. We got a lock MAC address. Wow, isn't that awesome? So the program is working. You can see the protocol. So the 0, you can see protocol here. This 0806 is our protocol, which stands for ARP, which is Address Resolution Protocol. So some of them we didn't have any MAC address, while some of them we have MAC address, different MAC address on the systems. We are getting their source and destination MAC address. So everybody on this network, I'm literally seeing their MAC address. Okay, the destination MAC address is address of other ports in the layer 2 switches in my network. Okay, so isn't this awesome? This is a very powerful program. So I know you guys are gonna love it. You can run this on your system to see different MAC address on the same network, not outside the network, on the same network. Okay, so you guys can see, cool, right? Some asked, like this one here, writing 8. You see my mouse 8080. This one is IPv4. This one also is IPv4. Why this one? Oh, okay, IPv4, IPv4. So it's like, you know, it's an everlasting loop. So I can just scroll up so I can see more. So some are IPv4. Okay, this one now is ARP, which is Address Resolution Protocol. Why is those one that have 8008 is using the protocol IPv4. Okay, so it's nice you know, hanging out with you guys. If we have a MAC a protocol here that is using IPv6, we will see 8D 5 something, that is for IPv6. So right now there is no IPv6 MAC address. There's no IPv6 protocol in this network right now, so you're not going to be seeing IPv6. So have a nice day, guys. And you can see it's still open through, getting all MAC address on the same. Now look at broadcast. So FFFFFF is the broadcast MAC address. You can see it here. So you just capture the broadcast, you can see it, and so on and so forth. So it's been education Agna with you guys. So see you guys on my next video. Have a nice day. It's your humble boy Pen. So see you guys. Bye. So Ctrl C to stop the application. Change to my home screen. I will just rerun that which I just run. And this. So this is what it's all about. Low level hacking MAC address and protocol layer 2 in Linux in C language. So see you guys on my next video. Have a nice day. Bye bye. Bye bye. Okay.